Okay, let us now look at sample distribution. Sample distribution, by definition that we saw earlier, so it is the probability distribution of statistic. So what statistic is? Statistic is actually the numerical descriptive measure of a sample, and statistics are used to um, give an estimate of parameter which helps us describing the population that we are studying. First, let us consider that this box represents a population. And then these are the members of this population, and in general we consider population to be very large, and we assume that we cannot get access to all of the members of the population, and hence we cannot collect data from all of them. And if this is a population, we need some parameters to describe this population on the basis of something. So that parameter is actually a numerical measure about the population that can be mean, that can be standard deviation, that can be variance, or that can be median, whatever we are interested in. So since we cannot collect data from all of the members of the population, we select small groups which are called as samples. We can consider these are the samples. One, two, 3, and 4. Let us consider we have obtained these 3 samples from the population. Let me make this one a bit bigger. Okay, so these are the samples that we have collected. All of these samples contain a few members from the population. Maybe these are this one contains a few, this one contains a few, these contain a few, and this one contains a few from the population. This is how I can represent it. This is the one, and maybe this is the second one, and maybe this is the third one, and maybe this is the fourth one. So I have grouped it, but these can be randomly selected. So these are the samples, and from these samples, in this particular case, I can say that all of these samples have a few members of population in each of them. So in this specific example that I've drawn, each one has 4. So the sample size here is which is represented as n, it is 4. And from each of these we calculate numerical descriptive measures which are called what? Which are called statistics. And these statistics can be generalized to estimate a parameter which will eventually represent population. So by generalization or by making inferences about the population, we mean that we are in the realm of inferential statistics. Now we are entering into the realm of inferential statistics, because we are collecting data from few samples from the population, and then we are generalizing it to make inferences about the population. And the way we collect these samples are called as sampling plans or sampling strategies. As you already know that there are three major plans or strategies that can be used for sampling, means for collection of samples, which are simple random sampling, number 2 systematic sampling, and number 3 stratified sampling. So whichever we feel appropriate for the type of study we are interested in can be used for collection of samples, and the inferences that we make from the statistics, those really do depend upon the method we use for collection of samples. So the distribution of this statistic that is obtained from each sample, this can be mean of each sample, or this can be a standard deviation for each sample, or this can be median of each sample. The distribution of this statistic is called as sampling distribution. So it can be plotted like this. Here it will be the statistic. Let us consider that is mean. The mean of the sample is represented as x bar on the top, and mean of the population is represented as mu. So you should remember that. Even I can write it here. Mean of population is represented with mu, and mean of sample is represented as x bar. Okay, so it will be represented when it is drawn on distribution curve or a graph. Its distribution will be called as sampling distribution. So roughly I can say that it is 1, 2, 3, 4 on and 5 on x-axis, and something 0.1, 0.2, 0.3, 0.4 and 0.5 on y-axis. So when we plot the x bar on x-axis, it will represent the probability distribution of statistics, which will eventually be called as sampling distribution. Okay, so this is the sampling distribution.